Hello everyone, welcome to our channel The Students Forum. Today in this tutorial I'll be discussing about one of the important topic for competitive exams like NVS, KVS, JEE, etc. So the topic is projectile motion. In most of the years questions are asked from this topic, and we worked on the previous year's questions and found the types of questions they ask. Before going to the discussion of the questions, first let's us have a look on the theoretical part and the important relations about the projectile motion. A body is said to be projectile motion when it is thrown near the earth's surface and it moves along the curved path only under the effect of gravity. And suppose one object is thrown from the point O. This is the surface of the earth and it will be projected at an angle. This angle is theta, called the angle of projection. After a certain time it will reach the height, which is called maximum height and denoted by h. The body will go at a horizontal distance. The distance is called the range of the projection, denoted by r. The angle between this point and the initial point is denoted by alpha. So if we take the x-axis and y-axis for the motion of the projection, certain topics we have to remember, certain relations like horizontal component of velocity. So I'll not be writing the whole name, just the formulas to remember. That is, one is horizontal component of velocity is u cos theta. Number two, the vertical component is u sin theta. The horizontal displacement is given by u cos theta into t, where t is instantaneous time. Similarly, if we find out the vertical component of displacement, which can be written as number 4, the vertical component of displacement, u sin theta into instantaneous time minus half gt square. The negative sign is for the gravitational force is acting opposite to the motion of the particle. Now the third relation, which is an important relation, is the change of velocity. So if we consider the particle is moving from here to here, if the point, this starting point is O and maximum height is A and the ending point is C, that the change of velocity from the initial position to the maximum height is given by delta u, suppose OA, equals to minus u sin theta. Similarly, for the whole path it is given by delta u OAC equals to minus 2 u sin theta. So as we have found out the change of velocity, the momentum component will also be similar. Just multiplied by the mass. Now, one of the most important relation is the time of flight. That is, when this object is thrown from this point and it is reaching here, the total time taken by the object is called the time of flight, and this time is double of OA plus AC. So if we find out the time of flight, which is given by the vertical component of final velocity equals to initial velocity plus t. Now the vertical component of final velocity will be 0 because the motion will be along horizontal at the highest point. So 0 equals to u sin theta plus t by 2, because is on the point A the time is t by 2. Therefore from here we can write t equals to 2u sin theta divided by g. So this is one of the most important relations you have to remember for the competitive exams. Now next point is horizontal range. This relation also one of the important horizontal range. So many questions came during the last exams from the horizontal range. So horizontal range is given by r equals to the horizontal component of velocity into the time of flight. So as we know the time of flight is 2u sin theta, so the final format will be u square sin 2 theta divided by g. This is also most important. Now different exams have the question, what is the maximum range? That means if the object is thrown in a certain angle, what will be the maximum distance horizontally it will reach? So for that case we have to see sin theta equals to sin pi by 2. That means theta equals to pi by 4, 45 degree. So we have to remember at 45 degree angle, if one object is projected upward, the range will be maximum, and the maximum range is given by r equals to r max equals to u square by g. This is also important relation. Now the last important relation is maximum height. That means the maximum height to which a projected body can reach vertically above the point of projection. So from here, if one body is projected, this is the maximum height. So how to calculate the maximum height? Let's see. Maximum height is given by h equals to u sin theta, the vertical component of velocity, into time, that is time is t by 2, minus half of gt square. Okay, so if we put the values, u sin theta into t, value of t is 2 sin theta by sorry 2u sin theta by 2g, and minus half of g into the value of t again, 2u sin theta by 2g, 2u sin theta by 2g and whole square. Simplifying this, we will get u square sin square theta by 2g. So the time of flight, horizontal range, maximum horizontal range and maximum height, the most important relations. So from since last 2-3 years, the questions are coming from these parts. Now these parts we have completed: velocity, displacement, time of flight, horizontal range, maximum height. Now we'll come to the important questions. So here I am not writing the whole question, I'll just explain the question and try to find out the solutions. So NVS PGT 2019 question was like this. A ball of mass m is projected from the origin of coordinates with a velocity u, making an angle theta with the horizontal at the point alpha beta on the plane of the trajectory of the particles. The total mechanical energy of the ball will be. That means the ball is projected at an angle theta. Suppose this angle is theta and the initial velocity is u. So this component will be u sin theta and this is called u cos theta. Now we have to find out the total mechanical energy. So as it is given, suppose at a point alpha and beta, we have to find out. So we have to remember, for any point the kinetic energy of projectile is given by half mv square. Half mv square. So v square here, the horizontal component. So u cos theta whole square. That means half m u square cos square theta. And the potential energy is given by mg into h, the height. H is the height. So here, if we put the value of h, m g into u square sin square theta divided by 2g. That means m u square sin square theta by 2. Now these two equations are giving to the total energy, that is called the mechanical energy. So if we write the total energy or the mechanical energy is given by kinetic energy plus potential energy. That means half mv square, half m, that is u square cos square theta plus sin square theta. That is, the value is 1, there will be half mv square. Here it is u square. So the option is half mv square. Next type of questions are coming. A projectile, when fired at a certain inclination, has maximum range r. The maximum height obtained by it is in terms of r is. So here we have to find out the relation between the range r and the height h. So r equals to r max, we have already discussed, equals to u square by g, and it will be maximum for theta equals to 45 degree. Therefore h max equals to u square sin square theta, theta means 45 degree, divided by 2g. So u square by 4g. So as we know, the r max is, that means r by 4. So this relation came. Next, one of the most tricky question and important question is, a particle is projected making an angle of 45 degree with horizontal, having kinetic energy K. The kinetic energy at highest point will be. So it is given that the object is projected 45 degree angle. Angle of projection is 45 degree, and the kinetic energy is given by K. So what will be the kinetic energy at this point? What will be the kinetic energy at this point? So different options are given. Let's see what is the result. So kinetic energy is given by half m v square. Suppose v square is the velocity of the projection. At highest point, v equals to, at highest point, v equals to v cos theta equals to v cos 45 degree. Therefore the kinetic energy equals to half m v cos 45 degree square. So half mv square into half. So half into half mv square, that means this is K. So the kinetic energy at maximum height is always the half of the kinetic energy at the starting point of the projection. That question came in CBSE 2001. Now I'll be discussing one IEEE question which is came in 2012. A projectile thrown with a speed v at an angle theta has a range r on the earth surface. For same v and theta, its range on the surface of the moon will be. So different options are given. Suppose the projectile thrown with the speed of v at an angle theta on the earth surface. So here they asked what is the value of range on the surface of the moon. So for that we have to find out the value of the range. So as we already know, the range is given by u square sine 2 theta divided by g. That means r proportional to 1 by g. Now r max divided by, here we have to find out r. So r at moon divided by r at earth is given by g So as we know, this relation earth to moon is around 6. Therefore r at moon is equals to 6 into r at earth. So for today our discussion will be up to this. We'll continue with the answering the questions from the previous year questions and important topics. Thanks everyone being connected with us and watching the video. If it's helpful, please like, share and subscribe.